Welcome to lecture number 3 for lesson 1, and we're going to be talking about another one of Earth's systems, and we're going to be talking about the one that has all of this blue stuff here, all of this water. We're going to be talking about the hydrosphere. The hydrosphere. So the definition, according to our textbook, the hydrosphere is the system containing all of Earth's water. So I want you to keep that phrase in mind, all of Earth's water, all of it. So we're going to see some maybe places with water that you didn't quite expect. But let's talk about the word itself, hydrosphere. So sphere, again, we know, sphaira, globe or ball. But the hydro portion, you're going to see that over and over throughout science, hydro, hydraulic, hydroelectric. There's a lot of things, hydrolysis, that use that prefix hydro, but it comes from the Greek word hudor, which means water. Water. So anytime you see hydro, you're going to automatically know it's talking about water. So this is the sphere of water. And just to give you kind of a figure on how big the hydrosphere is, the hydrosphere contains more than 1.3 billion square or cubed kilometers. So kilometers cubed. So that is a three-dimensional figure, 1 kilometer by 1 kilometer by 1 kilometer. So think about that in terms of size, that kind of visualize a cube that is 1 kilometer long, 1 kilometer wide, and 1 kilometer tall of water. So 1.3 billion of those. That's a lot of water. So let's first talk about where we find water. So places that naturally you find water stored is a reservoir. It's a natural location where water is stored. Sounds about right. I'm sure you've heard that word reservoir before. So we know that's what it is. That when we talk about places that it's naturally just sitting there, it's a reservoir. So the largest reservoir is the ocean. So this is a shot from Antarctica of Earth's ocean system. Now we name different oceans, but really when you look at it, there's one world ocean. And so here's an interesting map going back to our chapter 1 map skills. This is a map view of Earth's oceans. Here's the South Pole, so there's Antarctica, and the Pacific Ocean, all that. The Atlantic Ocean, Indian Ocean, up into the Arctic, so you can see how they all connect. This is all of Earth's ocean, one big ocean. That is a huge reservoir. More than 40% of Earth's surface is covered by this water. This is a huge portion of what our planet looks like, and you can see it looks blue, not just because of the way that light is diffused from the outside, but the ocean itself is looking blue because of the way it diffuses light. So let's talk about the ocean. So we know that this is, again, our biggest reservoir of water, but how much of that is useful? Water is salty if you've been to the ocean as compared to a lake. There's a big difference. I grew up in Michigan where we're surrounded by the Great Lakes, and you have these monstrous lakes you can't see across, and it's not salty water. And then I move down here and I go to the ocean, and there's a big difference in that water. You can't drink it. It's not usable. Why in the world is there so much salt water? Well, that has to do with some properties of water itself. So if you look here, you have these red and white are water molecules. So the red, that's the one oxygen, and the white, that's the 2 hydrogen. So this is a water molecule, and this is salt. This is sodium chloride. And so one of the chemical properties of water is that it's known as the universal solvent, but things dissolve very well in water. So salt, which is an ionic bond, and you don't need to know, I'm not going to test you on that, but I just want you to understand why things dissolve so well. It actually breaks it apart because of the polar properties of water. So it pulls it apart and it dissolves it in the water. That's why salt will disappear into water. But we can't drink that. That's not good for us. That's not good for animals. We need water that doesn't have all of this salt. So there's fresh water. Fresh water is any water that contains less than 0.2% of dissolved salts. Now, that's kind of a rough figure. So you'll find water that's called fresh that has different amounts of salt in it. But ideally, this is the percentage that we're looking at in order for something to be considered fresh water. So let's look at the way Earth's water is distributed. So 97% of all of Earth's water supply is in the oceans. So that other 3% is fresh water. So out of this 3%, 70% of Earth's fresh water is in ice caps and glaciers, and 29% is in groundwater, which we'll talk about those things in a little bit. But 1% of fresh water is easily accessible. That's not a great figure, considering that we need fresh water to survive, and your land animals need fresh water to survive. So what that's kind of a small figure. But now, of that 1% that's easily accessible, 52% is found in our lakes all over the world. 52% of the 1% of easily accessible fresh water, of the 3% that is fresh water, is found in lakes. 1% of that is found in rivers. 38% is in soil moisture. 1% is water vapor, meaning it's in the atmosphere, so clouds and things like that. We see that's our 1% of easily accessible. And then there's water in living things. So we see the hydrosphere actually touches all of the other spheres. And when we get into the next lesson, we'll see kind of the interaction between the different systems. But I want you just to look at this, and we'll refer back to it just to kind of look at how Earth's water is distributed. So let's talk about lakes and rivers. So of that 1% of fresh water that's easily accessible, 52% is in lakes and 1% is in rivers. This is a big source of water since the beginning of human civilization. If you notice, most major cities throughout history were built near some major source of fresh water because we need it. A lot of cities were built on rivers. Now, granted, sometimes on the ocean, but it was best to have some place where they could get fresh water. We don't have the same kind of limitations today, but most of your major cities throughout history are going to be built near some source of fresh water. Now, let's talk about this other 29% here of fresh water. 29% is groundwater. Groundwater is water that is stored in cracks and pores beneath the Earth's surface. So here's kind of a graphic that you can see. So water will seep in through a process called infiltration, which we'll get into later, and comes down into these cracks and pores in the ground. And then you've got what's called the water table. And this is the line between the groundwater, so the saturated area of the ground, and an aquifer is a place where it's stored underground, and then the unsaturated part of the ground. So we can dig down. Now, where we are, our water table is actually very high because we're on a coastal plain. So you don't really have to dig down very far to get to this ground table. But that's the difference between the unsaturated area and your groundwater. Now let's talk about the other portion. You've got the 70% of fresh water is in ice caps and glaciers, and that is part of the cryosphere. The cryosphere is the frozen portion of water on Earth's surface. So cryosphere. Look at the word here. Cryo, we know, again, no sphere, from sphaira, globe or ball. Cryo comes from the word kruos, which means cold or ice. So it is the realm, the area of cold and ice. So we use it to refer to the part of the hydrosphere that's frozen. So let's look here. We've got different areas that are considered part of the hydrosphere. Snow and ice sheets, glaciers, icebergs, sea ice, permafrost, ice on lakes and rivers, snow on mountains. You see those snow and ice caps. All of this is quite a bit of the fresh water on Earth's surface. And we don't really think about that, especially here where we don't really see a lot of the cold and snow, but 70% of our accessible or of our fresh water is not accessible because it's in these ice caps and glaciers. Now, we don't necessarily want those to melt, but that just lets you know what amount of water is sitting there at our ice caps and sitting on top of mountains and sitting in these cold weather areas.